There are two ways to do this problem. The first one is quick and dirty. The second one is a little bit more slow, but it's rigorous, and I want to take a look at both of them. But the first thing I want to do is I want to factor 105. 105 is equal to 3 times 5 times 7. So what we're looking for is we're looking for positive integers less than 1,000 that are not divisible by 3, 5, or 7. Well, we know that there are 999 positive integers less than 1,000. If we want the ones that aren't divisible by 3, well, that's going to be about 2/3 of them, because if you're looking at a large set of consecutive numbers, every third one is divisible by 3. So about 2/3 of them are not going to be divisible by 3. So then we're looking at the numbers that aren't divisible by 3, and we want to know which ones aren't divisible by 5, and about 4/5 of those are not going to end up being divisible by 5. If we've got a large set of numbers, consecutive numbers, then we would have 4/5 of them not divisible by 5. These aren't consecutive numbers because we've taken out every third one, but because 3 and 5 are relatively prime, they don't actually affect each other. So 4/5 of these numbers are not divisible by 5. And then lastly, we're checking for divisibility by 7, and I'm going to claim that about 6/7 of the numbers are not going to be divisible by 7. If you look at all whole numbers, 1/7 of them are divisible by 7, so 6/7 aren't going to be divisible by 7. This is not going to be perfect, but if we plug all this into a calculator, we get that this is approximately equal to 456.69, which is about 457, and that happens to be answer choice B. Now let's go through and be a little bit more careful. Let's start by looking at the numbers that are divisible by 3. I'm going to write a division sign in 3 to mean the numbers that are divisible by 3. There are 999 numbers, positive integers less than 1,000, and we know that 1/3 of them will be divisible by 3, so that means that 333 of them are going to be divisible by 3. Let's look and see how many are going to be divisible by 5. We've got 999. If we take that and divide it by 5, we end up with 199.8. And the reason we have that 0.8 is because we consider the numbers 996, 997, 998, and 999, but not 1,000. If we considered 1,000, we'd have an even 200, but we're not considering that 200th number. That means that there are 199 numbers that are divisible by 5. Similarly, if we want to look at the numbers that are divisible by 7, we can take 999 and divide by 7. We get 142.7 something, but we're only going to have 142 because that extra 0.7 consists of the last few numbers less than or equal to 999 that aren't actually divisible by 7. So we've got 333, 199, and 142, but we're actually not counting correctly. I want to consider now the numbers that are divisible by 15. We already counted those numbers when we were looking at the numbers that were divisible by 3, but we also counted those numbers when we looked at the numbers that were divisible by 5, because numbers that are divisible by 15 are divisible by 3 and 5. So we've counted these numbers twice in this list. So what we need to do is we need to figure out how many numbers are divisible by 15, and we need to get rid of them so that we're only counting them once. If we take 999 divided by 15, we get 66.6, which means there are 66 numbers that are divisible by 15, and we counted those twice in those first 3 groups, divisible by 3, divisible by 5, divisible by 7. So we're going to need to subtract these out of the group eventually. But we've also overcounted the numbers that are divisible by 21? Because we counted those numbers in the group of numbers that was divisible by 3, and we also counted those in the numbers that were divisible by 7. So we need to take these and we need to pull them out as well. 999 divided by 21 is 47.57 something. So there's actually 47 numbers that are divisible by 21, which means they're divisible by both 3 and 7, and we ended up counting them twice, so we've got to get rid of them. And then lastly, if we look at the numbers that are divisible by 35, we've also counted all of those numbers twice because we counted them in the numbers that were divisible by 5 and also the numbers that were divisible by 7. If we take 999 and divide it by 35, we get 28.54 something. So there's 28 numbers that are divisible by 35 that we had counted twice. So if we add up the numbers in these rows, we had 333 plus 199 plus 142. If we just count all of those numbers, we get 674. But then we have to remember that with those counts, we counted all of the multiples of 15, 21, and 35 twice, so we have to get rid of those. If we take 66 plus 47 plus 28, that gives us a total of 141 numbers that we've counted twice, and we've got to subtract that from 674. But there's actually going to be one more step. Let's think of the numbers that are divisible by 3, 5, and 7. Those are the numbers that are divisible by 105. Well, if we take 999 and divide by 105, that gives us 9.5 something. So there are 9 numbers in that group. But let's think about how we've counted them. If a number is divisible by 105, we counted it once when we looked at the multiples of 3. We counted it a second time when we looked at the multiples of 5, and a third when we looked at the multiples of 7. But then we got rid of it when we looked at the multiples of 15, and when we looked at the multiples of 21, and we looked at the multiples of 35. So we counted it 3 times, and then we got rid of them 3 times. So we didn't actually count those numbers at all. So we're going to have to add them back in. We're going to have to add in those 9 numbers in the end so that we remember to count them. Now if we take 674 minus 141 plus 9, we end up with 542. But these are the numbers that are divisible by some of these. We wanted the numbers that are relatively prime to those numbers. So what we need to do is we need to take that and subtract it from 999. And if we take 999, those are all of the positive integers less than 1,000, and we get rid of the ones that are not relatively prime to 105. We are left with 457, which is the number of numbers that are relatively prime, which again is going to be answer choice B.